Good day, class. I want to talk about the complexity of the supply chain system. Think about what a supply chain system would look like for an airline or military if the aircraft were delivered serviceable, would never fly, and no maintenance would ever be carried out. This model would be very close to a static display at a museum, no parts needed. I'll argue that the first layer of complexity for the supply chain system comes from the preventive or scheduled maintenance program. For this example, we can factor in inspection requirements, modifications, and upgrades. With an ability to forecast maintenance weeks to months in advance, the supply chain demands are not overly complex at our MRO. Complexity starts to increase when considering the corrective maintenance program. The need to have a subset of parts available to perform this maintenance function is challenging. Failure modes analysis can assist in estimating potential failure rates to forecast what parts may be required and when, but there will always be a scenario to source a part that has never been ordered before. Our inventory and supply chain systems start to change drastically as the flying rate increases. One can easily assume that the more organization flies, the more unscheduled and scheduled maintenance will need to be conducted. The supply chain system needs to be flexible and dynamic in maintaining sparing to meet a given flying rate or operational status. As briefly touched on, the maintenance schedule and flying rates will detail what parts may be needed, how many of them, and when they will be required. However, from a business perspective, it's unrealistic to house 100% of the parts all the time. So decision makers need to analyze failure rates and methodologies to formulate. Keep in mind, however, that the aircraft that is available today is not going to be the same aircraft that is available tomorrow. As the aircraft ages, new inspection requirements will need to be tasked, new failure modes will appear, wiring will begin to degrade, all leading to new problems, and an increasingly challenging problem to find where to get these parts. In an ideal scenario, there will be a vendor available that will have in stock the part you are looking for and are willing to ship it at an agreed upon cost. However, there are certain components, think leading edges as an example, that may require a specific lead time before it can be shipped. These items that do need to be manufactured first. Urgency comes at a premium. We see this today when we're buying something on Amazon as an example, and the free option for free shipping comes with longer delivery times, but if you want it the next day, it comes at a cost. And our supply system is no different. How much a company is willing to spend on spares or sparing services will drive a specific operational. Building on the complexity of the problem, one more time, is where the part is needed. The proximity of the broken aircraft to the vendor will provide the highest response time. However, ITAR regulations, diplomatic clearances, flight availability, shipping times, locations will all affect supply chain's ability to get that specific part on site. Lastly, and I talk a lot about this here in Canada, is this idea of playing Tetris at level 20. For our supply chain system, it is a constant, never-ending battle of quickly absorbing new information about parts requirements, interactions with vendors and shipping companies, staying within an allocated budget, and doing what is required ultimately to make a line.